And we're back. Hello, everybody. Welcome to another cool workshop for the Encode Summer Hackathon sponsored by the Solana Foundation. Today, we are joined by an amazing speaker from Helios, Hunter, who will be holding a workshop on compression on Solana. Yeah, if you've got any questions, feel free to pop them in the chat. And Hunter will get to them either during the session or at the end. Yeah, Hunter, feel free to start the workshop anytime you are ready.
Okay, perfect. Yeah. Good morning, guys. So today I basically just wanted to go over something that's pretty prevalent on Solana right now, which is compression. A lot of people don't have any knowledge or interaction with compression, so I just wanted to go through a quick example in which we're going to be going through minting some from a CLI here, and then afterwards we'll download a cloned repo of X-Ray, which is the blockchain explorer, which we could interact with compressed assets and at least view them as your wallet adapter does. So let's just get into what compression on Solana is here. So compressed NFTs cost approximately 1% of the usual price to mint. Um, that's essentially just because they don't have to be stored in a regular token account. So they're not taking up that 0.01 Solana to mint or transact with or get on the blockchain. It's all pretty much just stored onto onto a Merkle tree. So it's all still stored on the Solana ledgers. So I think aspect of it being all off chain is it's not really realistic or true. And then Helios's part of this is that we're just tracking and indexing all of the Merkle trees and compressed assets. So we're able to retrieve them whenever developers want to call them for specific reasons. So if you want to interact with them or transfer them, you're just able to based off of that. And then, as I mentioned before, the compressed NFTs are stored on the Solana ledger. The validity of a Merkle tree is checked using something called the root hash, and that is something that you end up retrieving, per asset. And for any sort of modification to take place, you have to get the proof of that asset, and that's just some data verification that is just being allowed on the Merkle tree. And then what is a Merkle tree? A Merkle tree is known as a hash tree or a binary tree structure. The leaf nodes are represented in individual hashes on the Merkle trees. So they all have their own individual ID and they're all represented by an ID. And they're all just kind of branched out based off of that. And then climbing the tree, all branches are hashed together until a single hash root remains. This is how you end up, verifying the data integrity there for the Merkle tree. So you're allowed to have all of these different assets that are stored on chain on this Merkle tree account. And they're all able to be verified as being part of that collection or belonging to, that user who's creating the assets. So the key difference between regular and compressed assets is that compressed assets, as I mentioned before, just don't have that token account. So you don't have that 0.01 SOL or rent obligation. You're instead, storing this alongside the Merkle tree. So it's not being stored technically on an account itself. The Merkle tree itself is on a regular token account, and that's a majority of the SOL that you end up spending. So in this demo that we'll go through, yeah, in this demo that you go through, you basically end up having a majority of the SOL that's spent be based on creating the Merkle tree. So I think in normal situations, whenever I set the max limit, which we'll do in this demo here, to 15,000 NFTs, the SOL storage ends up being, I think, around 0.22 to 0.25 SOL, which is not a total of a lot compared to minting 10,000 NFTs on the Solana blockchain before. That would cost anywhere between I think 20, 30 SOL. And the program that it's usually interacting with is the bubblegum program. So that's just using it to store the NFTs on the Merkle trees itself. And then minting compressed NFTs just includes appending what's currently on the Merkle tree. So anytime you mint, it's just indexing where the last asset was minted. And then with Merkle trees, you could actually have multiple collections stored on one Merkle tree, or you could have one collection stored across multiple Merkle trees. And it's not recommended that you have multiple collections on one, I guess for data integrity purposes. And most times people will set their Merkle tree to private, so you can't mint any other collection on there. But if you wanted to truly save space, you could always locate a public Merkle tree and mint your collection there and save a bit of cost depending on the size there. I guess like the issue with that is that most people just want to have their own private Merkle tree. So there's just like no uh, just mixing up there. And then it basically just eliminates the need for the mint and token and metadata accounts. So like usually you have like a token account that has like a URI, like a JSON URI that's pointed towards, what the image or GIF of that NFT is. And then in the case of a, compressed asset, you have the Merkle tree, you get a leaf ID and an asset ID, and you're able to point to the assets URI that way just by like calling on indexers such as Helios or Triton One or Simple Hash. They all support the DAS API, and the DAS API is basically just allowing you to interact with these like supported modifications. So like if you wanted to mint, transfer, burn, delegate or cancel delegate, redeem or cancel redeem, redeem and cancel redeem, those are basically used for if you're going to be, decompressing an asset. So if you wanted to store it in a token account, you could pick it off of the Merkle tree. And then there's this process where it's stored in a voucher PDA, and you're able to essentially just have it stored in a regular token account at that point. And that just leads to like decompression, which like you're converting a compressed NFT to a regular Metaplex NFT. And then if you were to unverify the creator, and you can do the same with the collection. And that's basically just allowing you to set a public key of some sorts to be the verified collection ID or the verified creators of that collection, just as like a regular collection would be. I don't know if you guys have any experience with that. Now, for reading compressed NFTs, as I mentioned before, you need the DAS API to do that, and API calls are required to read information about that. Now, DAS API is the Digital Asset Standard API, so you're basically unifying compressed and regular assets. So if I was to make a call on that, there are various different endpoints that I could hit there. So I could grab all of the assets belonging to a user or to a creator or to a authority or to a collection ID. And then you could even switch this to search assets, which is like an endpoint that basically gives you a wildcard to pick out specific things. So if you wanted to see a collection that belongs, like a certain collection ID that belongs to a specific wallet, you could filter based off of that. Or if you only wanted to return compressed assets that belongs to a wallet, you could do that as well. And to just go down this list here, all modifications happen through the bubblegum program. So if you're trying to transfer or burn or do anything there, you need to grab the current state of that asset. And most times you need to use the DAS API to like return some sort of information that is just relating to that. And that's what makes it like really awesome, is that you don't have to then use another API endpoint to return, regular standard Metaplex NFTs that are stored on a token account. It's returning all of those together. You could just end up distinguishing if you want to view your compressed assets or the regular assets. So that's a really fun part about it. And then the indexer functionality, we're basically indexing bubblegum transaction and updating its state. And we're fetching the transaction history and reconstructing the state of Merkle trees, which essentially just means you're grabbing like who the current owner is, what that data hash is, because that can end up changing based off of, any sort of modification to it. So you definitely have to be grabbing like its current state. Most times you'll run into an error if you end up grabbing that information that was like a little bit stale or a little bit older, and you'll get like a creator hash error or a data hash error just saying that the proof root can't be mapped just because the data is a bit older. I think that's the exact error that you end up getting. And this is like an example of actually just retrieving like an asset proof here. So you get the root, and then you get the actual proof itself, the leaf, and the tree ID. The tree ID is what ends up like tying like all of those assets to a specific tree itself. That doesn't necessarily mean, as I mentioned before, that it's all the same collection, because you could have multiple collections stored across, the same Merkle tree, or you can have one collection stored across multiple if you wanted to. So it's not really tied to that specifically, and I wouldn't look at a tree as being a collection just because it can end up splitting that way. So if you're looking at a tree, just look at it as like a place where, multitudes of like assets can be stored, whether it's one collection or multiple collections. So that's like usually the way that I split it up here. And then an example of that, a lot of DPIN products are using them, such as like Helium and Render and Hive Mapper. So they're using like compressed assets to, grow their networks in the way that they are. And those are very like cool use cases. Dialect uses compressed assets just to mint their stickers. So that's something that's like very awesome as well. And it's very low cost. So like people are able to like have like this very quick mint experience, and I think they run like a few a week, or at least one a week. And then like Tensor, they upgraded their marketplace to support compressed assets. So now you have like generative art collections or drip collections that are able to be sold at mass and traded at mass just based off of that. And it's a very cool use case that ends up just continually expanding. So I could see a lot happening with like game assets, or if you had to update game assets, or go through a variety of them, it doesn't cost as much on chain anymore as it would with like something like compression, just because it's going to be costing a literal like 1%, whereas like you're maybe spending that 0.01 sol on each mint. And we'll actually go through like a few transactions when we go through the mint process here, but when you're spending that 0.01 sol versus a mint compared to the 0.00005, like basically whatever a transaction fee is for a mint, it ends up changing the game quite a bit. And it doesn't mean that you have to set that as like any type of pricing on it. But that's the general idea, is just to get it on chain, it's a lot cheaper. And then today we're basically going to just go through mint cNFTs through a CLI repo, which I'll end up posting in the chat here. Afterwards, after we mint them, we're going to download, or we're going to clone X-Ray, which is a blockchain explorer that's open sourced. And all we need there is a Helios API key for like both of these guys. And we'll go through and interact with them as well after we're done minting. And if there's like any questions in between, I'll just take a look at the chat here. So here, let's go through, and the first thing that I want to do is send you this repo here. So this is my compression repo. It basically just allows you to set everything in the env here and be able to mint, but we'll walk through like some pieces of code. And then I also want to go through X-Ray. This is going to be the second thing that we end up cloning. And I'll post the repo link there. And X-Ray is just basically going to show us like how we're able to interact with these compressed assets. Now, in this case, it's just a view. Obviously, if you're like creating the compressed assets, then you have the ability to transfer, burn, use all the modifications that are available to it. I think in most cases, people just want to see like how you're able to return them and actually get them, in a visual standard. So we'll just do that with X-Ray, just because one, it's like the best way to show like how you're able to interact with compressed assets, and they're actually like one of the first to allow interacting with compressed assets on mainnet. Explorer.solana is really good as well for like any sort of devnet test. So we'll use that for the initial test here, just so we don't have to use any actual SOL. So we'll go through here and let's just download the compressed NFTs here. And let's go through to our Visual Studio Code. So I'll make a new directory called enc, and we'll just cd into that, and then I'll just git clone there. And then I will go through and open this up. Let's go to documents. go to Encode. Perfect. All right, awesome. Let me just make sure everything's good here. Awesome. Actually, let me delete this here. And I think I went into the wrong folder, but we will clone into this one. Perfect. So I'm just grabbing the most recent updated one. Now, if we check out the M, just before I go into anything else, there is an M file that I have like preset here. It's preset with like a few wallet addresses, and also preset with a free Helios RPC link. But essentially, I just want to walk through a few of these values first. So initially, I had this split for Solana RPC and Helios RPC just because it wasn't really meshing well to have them merge together, and I'll end up making a PR later that ends up merging these URLs just because it can just be the Helios RPC URL. But I ended up having these like split out just because I think initially when I was using this compression, DevNet Solana wasn't really, reacting too fairly to, interacting or minting them. So I was getting a bunch of like errors there, and it just made sense to split at the time. For the Merkle tree source, that is basically the wallet or key pair that we're going to be setting as the Merkle ID in the tree ID. So this won't end up being our values, so we can just take this out. We'll create some new wallets here. The key pair source, this is what's going to be funding the entire mint. So essentially, we'll just be supplying this wallet with like one DevNet Sol, and we will be able to mint from there and mint our assets, create our tree with just one DevNet Sol. I think you can end up minting about 15,000 assets for around 0.7 or 0.8 Sol if you were to do it. So it's very lightweight and cheap. I ended up just selecting like a collection metadata, preset link here through Arweave. Feel free to use, if you have like a handy like JSON URI that like is for collections or NFTs, feel free to throw in here. If not, you can end up just using this collection metadata link and the NFT metadata link. And then the collection mint wallet, that's basically when we're minting the cNFTs, we're going to be minting them to a collection ID. So here we're basically creating the key pair source. And then in the mint portion, it's basically just asking for the collection mint. So I ended up having them split out just for like teaching purposes, just so you're able to see like the differences here. So this ends up being just like the public key of this guy here, this key pair. So we'll take this out as well, and we'll end up creating another one. And the asset ID and the index NFT, these are values that I had set when we were transferring the cNFTs, and that takes a little bit of setup in itself. So I won't go over that today, but if you guys have any questions on like how to do this or like use any modifications afterwards, feel free to let me know, and I will I jump on a call or happily like hop on a stream and show you guys how to like use these modifications. So we could actually just take these guys out here. So these are like basically like our main environment variables, and I'm gonna grab a new Helios API key. I think I've maybe burned through this one through like enough demos here, but let's go through, and I will send you guys the link to helios.dev, which just allows us to sign up for that key here. And if you go to launch dev portal, let's create a new wallet here. So let's call this create new account, Encode, create it, and perfect. So let's approve here, select our wallet, go through our transaction signing, and we're going to get this pop up here. That's basically just going to say to generate a Helios API key. Just click that, and within seconds you end up like having one that's pretty available. And we're just going to grab the DevNet one here. So with DAS and with, I would say compression in general, whatever RPC you're working on is where those compressed assets are going to be minted to. So I would keep that in mind. So if like you're initially using a mainnet RPC, those assets are just going to be on mainnet and they're going to be using mainnet Sol. It's really good to test on DevNet because you're not using any real funds. So I would keep that in mind, but we're going to go through and select the DevNet RPC here. And we'll go through and input this into our Helios RPC here. And we'll go through and copy and paste this over. Now, another thing that we're going to need is going to be the Solana CLI. Ooh. So if we go to this link here, this is just to generate the wallets on the actual repo itself. So here I will send this. And yeah, there are multiple ways to install this via Solana for sure. I'm just using the SH method here. So let's go through and actually start downloading this. Now for like creating the Solana wallets themselves, there is the Solana keygen new. Oh yeah, here, let me increase the font here. Of course. All right, is this good? Just let me know if it's not or if I need to increase it.
Yeah, I think this will go to thank you.
Perfect, perfect. Okay, so basically like when we have this, I like to go into CD source. I think we have our, what we could do is we can create our wallet directory here. And so CD compression NFTs, CD source. I'm just going through it step by step, just in case anybody is a bit lost here. So I'm just going into this wallet directory that I added under the source folder. And we could end up doing Solana keygen grind starts with H3. So now we have 3 wallet key pairs that we created here. I'm just using 3 or the letter H just so I run these tests a lot and I end up like mixing wallets up here. So I just use the starts with command and then I use like the letter and how many wallets I want to create. We just want to create 3, one for the Merkle tree, one for the key pair source, and one for the collection ID here. So we could actually just start copying those in to the values that we removed before. So this can end up being the Merkle tree one. This could be the key pair source. And then this guy can be the collection mint. And we could just grab this. Awesome. Now, if we wanted to, so we could grab this one that we set for the key pair source and just go through and airdrop some Solana to it. So let's just go to a Solana faucet here. I don't know how technically savvy some people are here, but you can end up having this set to the CLI and doing the airdrop portion that way. I've just found some issues with that in the past, just like running into like rate limit things, and it ends up not being too fun. So if you end up using this site here, which I will drop in the chat, it ends up being a little bit easier sometimes to get the DevNet Sol. There's for some reason a huge drought of DevNet Sol on Solana, so it ends up being a fun time trying to get it whenever you're like launching programs or doing tests like this. So let's actually copy this key pair source over that we have. So our key pair is HTIM. So if you grab this, each file that's generated, we're able to take this and copy it, and we can go into our Phantom. And we could actually just add this and import via private key and just call this compressed test. Perfect. And if we're on DevNet, it already airdropped that one Sol. So I would use that method. If you want to do it via like the CLI, by all means. I would even follow like more of the Solana CLI documentation. You can find out some like really cool things to do there, and it's pretty expansive. So now that we have our one sol, we could actually get out of here as well. And let's go to our repo again. So let's go to our M folder, and we have everything set here. So our collection size is going to be about 15,000. The collection mint wallet is going to be this. Our collection metadata is going to be the same exact thing as the NFT metadata. So these guys are going to be, pretty hand in hand here. You can end up, changing that around if you wanted to. If you're doing like a generative collection, this is just minting like one image itself. So if you wanted to like loop through like a cache folder or something where like the images are already like uploaded to something like Shadow or Arweave, by all means, you always can. And then you can have them minted in like a row. So that's like another idea of how to use this repo here. But the first thing that we're going to have to do is going to be creating the Merkle tree. I set everything into short commands. So all we have to do to actually create this is npm run Merkle, and that'll use the key pair source to end up, generating that Merkle tree itself. And it's using the key pair that we just funded that one sol to actually pay for it, which should only be about like 0.22 sol at the end of the day. But within this file, I just want to go over a few things. One, we're loading in the Merkle tree here. So we're just loading that in from the env. If you wanted to do this locally, or if you wanted to throw something up quickly, you could always do that. I just set everything to the env file just so for these lessons, it's like a little bit easier to like follow along with. Now, one thing that's like pretty important is the depth size pair. That's something where you're basically defining the size of what that Merkle tree is going to be here. So if you're going to be having something that's going to be, 50,000 NFTs or 50,000 assets or 1,000,000 assets, you would adjust this based on the max depth here. Which I think for that, you just do like log to 14, and that'll end up giving you like the or log 2 and the number of NFTs that you end up doing, and that'll give you the max depth or around the max depth that you could use here. And there's set like definitions or set max depth that you could use here. And for max buffer size, you typically use 64. But this is basically just where you're defining, okay, this is how big our Merkle tree needs to be to mint all of our assets. You want to make sure that I would say this is like the most important planning ahead step that you could do, because if you're going to have, 1,000,000 assets, or if you're anticipating a large amount of assets, you don't want to limit yourself at this stage. Now, if you do end up limiting yourself at this stage, you can create another Merkle tree to mint your assets to. So it's not too big of a deal. But if you wanted to like keep that integrity of like having everything remain in one place or on one Merkle tree, it's always a good idea too. One example of that is like Drip. Drip ends up using one Merkle tree, I think, for a variety of their collections, but they're mostly, in charge of all of that collection updating, even like the releasing and transferring of those NFTs. So for them, I think it ends up boding well. So after that, you're basically just saying and using the SDKs get concurrent Merkle tree account size, and you're saying, okay, this is going to be the size of this Merkle tree. And we're now just going through in these ladder sections here and just defining the instructions that we're going to be posting to Solana itself. And we're saying, this is the space that this Merkle tree is going to take up. You also have to pass in these program IDs, like the account compression program ID, the new program ID, the system program ID, which is like a pretty typical one to use here. And then you're defining like the Merkle tree public key and the payer for that. And that's pretty standardized and it can be customized to like whatever situation you have set up. So yet again, if you're minting on like multiple Merkle trees, you would maybe create these ahead of time, index them in your own way, or like, put them in a DB or somewhere and try to note where these assets are being minted to or up to what count. But it's a pretty important step just to keep track of like what size you guys have set here. And then down here, we're basically just sending the version transaction. So we're passing in the connection, which is to our Helios RPC. You could end up using the RPC from Solana DevNet. Sometimes depending on traffic, that could be a problem. So I would maybe just like generate a free key. You're not going to be charged anything extra. Nothing's tied to that wallet. and you're passing in the instructions that we set above here. So just creating the account tree size and creating the account where the Merkle tree can be stored. And yet again, this is probably the step where we're going to be spending the most SOL. So we started off with 1 SOL here, and we're going to look at the transaction signature after that this was created, just so we can look at how much this cost us. So this repo is pretty much set up just so like this step, if you wanted to adjust anything, you would maybe just adjust the size here of the Merkle tree. And if you guys wanted to mint like a larger collection on this, by all means, go ahead. But we'll just run npm run Merkle and actually just make sure that we have everything saved here. So we'll just run npm run Merkle. And this should end up producing a signature here. And the only DevNet one that's available here is explorer.solana. It's probably been like my mainstay in like learning Merkle trees other than X-Ray. X-Ray I use for mainnet just because it's easier to actually read these transactions. But here, if we just look at that signature that was produced in the CLI, you're able to see, the amount of SOL that was spent here. So 0.22, and this was funded basically to that Merkle account. And I think now if we were to look at this wallet address, our HTIM1 in DevNet, we have about 0.77. So it's that 0.22-ish that the Merkle tree costs to create via like the account. And then now we have a Merkle tree to post everything to, and it's not too much. But essentially, like if we were to look at this here, we could even verify some information on this page. So we could say, okay, this is creating an account for the tree. Here it's creating the tree. Here is the max depth and the max buffer size, and it's not public. So yet again, in this stage, we're also setting whether this is public or not. And that could be pretty important. So like here at this bottom step here, we're saying public false. We could say public true if we wanted other people to be able to post to this. And then they would be able to without having this be like a signer. Yeah, that's pretty much this for actually creating it. You actually, like if you wanted to verify any further, you could look at the program log here. It's saying an empty Merkle tree. So now we just have a Merkle tree that we can actually post to here. And that just brings about the next step, which is actually minting a collection to it. So to create a collection on Solana via like the Metaplex certified collection standard, you essentially have to have a token address on chain that is having every asset that's going to be under that collection pointed to. So essentially, you're just creating a token account and you're telling, every asset that's being minted there, this is the collection that is being minted under. And that would set the size of the collection as well. And with compressed NFTs, the collections can be kind of dynamic. So if you wanted to mint more, you could always do that. And it's not really like set in stone in that capacity, just because you could always add more to it if you wanted to, unless it was locked in some capacity. But here it's a pretty standard collection mint. So I won't go too much into this, but essentially like you're creating the account for the collection mint to be stored in. Down here, we're setting the metadata that we set in our env here. We're calling this Helios cNFTs. You could set it to whatever name that you guys wanted to. We're setting the creators here. I ended up running like a test where I was like verifying and unverifying creators. So like I was kind of like adjusting with that a little bit. With the collection here, I set it to null. It's because we're not setting the collection here. We'll be doing that in a later phase. And we'll be doing that in the mint phase, which is the next one. And here you're basically going through creating a collection NFT as you would a regular collection NFT. So we don't really document this too well just because it's not specific to compression. It's just a little bit different in how you separate it. So like here, we're creating the Merkle tree. Secondly, we're creating this collection NFT. And then thirdly, lastly, we'll go into creating or minting the actual NFTs here. So in this section here, where this is basically the mint section, this would be our next step where we're actually like minting the assets to the tree. But for the moment, let's just go through and run npm run collection, which this will mint our collection NFT here. And this probably takes the most out of any command to, or the longest out of any command to actually go through here. And this is probably just because it's actually creating a token account here and storing metadata to it. So this one can end up taking a bit, but if we wanted to verify whether that was done or not, we could actually go into our collection NFT or collection mint here. We could try to see if this was actually minted as a collection on DevNet. So yeah, it looks like that transaction went through as an unknown token. Might end up updating in a bit here, but we actually see that it's actually like it has minted here. So that's a good sign. Perfect. And this is probably the second costliest thing that you could do in terms of like total value in one transaction, because this will end up costing basically the amount of a standardized token account. So like here you can see like now our balance is 0.75 after making that. So the rest of our SOL funds could essentially just go to minting these assets, which is really awesome. And let's walk through that mint phase a little bit here. So here we have a successfully created NFT collection with this address. That's awesome. So now we have something that we could tie it to, and we could stop that script. Now, if we were to go to the mint portions here, we could end up just taking a look at like how this is a little bit different. Here, we're basically setting, the Merkle tree. I ended up setting like a number of transactions that it could loop through. So like in this case, when we run the mint transaction, it's going to just loop through like a variety of like transaction attempts. Since I think I'm going to end up making like a PR to it where like you could end up using batch transactions, and it ends up being a little bit more efficient, I would say. So here, when you're creating the mint instruction, there's a few things that I want to go over here, and that would be one, the Merkle tree. That's obviously like where we're minting to. Two would be the leaf owner. So technically, right now it's set as our key pair, but this could also be set as who you wanted this to mint to. So you could almost look at this as like a mint / transfer. So if I wanted this to mint to like my friend's address, I could just, switch this out to new public key. And then I could just set that public key here. And then I could obviously, I would do public key, and then I would set the public key here. So you could just set the, public key address there and have that mint there. Or if you were like dynamically, running through like a list or something, you can end up like setting that, but you would just really have to just set it as like a new public key. Here we'll just mint it to the key pair that we're setting for the example. But that's a really important thing that I want to like go over, is that if you set that leaf owner to any public key address, it will mint to that address without the need for a transfer. So if you wanted to save on, any further costs or any further potential cost or coding in that sense, and you knew where these NFTs were going to be going, this is a very important step, just because you can end up saving a lot of time. So say if you're doing like an airdrop like Drip was, and you had like a preset list of like 100,000 addresses that you wanted to loop through, you would essentially maybe even create like some sort of function that would, loop through this and change that leaf owner to the new address. And you could use each mint transaction as a mint / transfer. So that's something that's very important that I don't think a lot of people know or are cognitive of with the bubblegum program, but it's a very cool aspect of it, is that you're just able to almost set the owner right out of the gate for whoever this is. And it'll show up right in their wallet instantaneously, which is awesome. But don't spam your friends at all. That's a bad idea. For metadata args, you can end up setting like the collection. So here we're setting the collection mint, which I think up above here we have just defined from our collection mint that's stored in our env. But here we're verifying it as false. I could verify it as true if I wanted to. But I think I just had that set for a set verify or unverified collection modification that I was doing. You're setting if it's mutable or not. This is like just very regular metadata args that like you would see on any standardized NFT. or regular NFT, quote unquote regular, that's like not stored in a token account, or that is stored in a token account. And like here, we're setting the names for each individual asset. One thing that I've found is that no matter what you set as the name here, the JSON that's set will end up taking basically over whatever that name is if you have it set any differently. So like, let's say if you were minting a bunch of different JSON URIs, but this was set the same, and like in just about every case that I've minted a collection NFT to, it's always changed this value in some sense, just based off of what that JSON URI was. So I did like a 25 collection mint using this script actually, where I was just like asking for pictures on Twitter, and I wanted to go through and actually mint these guys. And I was minting, I think I minted 25 or 26 photos as collections on one Merkle tree, because I also wanted to just like test like what the implications were there. And it ended up going pretty smooth in terms of like, grabbing the data from like that JSON URI, updating it. And now I have like a wallet that is pretty spammed up with all these like collection NFTs that I created. But I just wanted to get comfortable with the idea of what a collection was with compression. And it's very much the same of what a collection is with your regular tokens, or token account NFTs. For the URI, that's what we're basically setting as the NFT metadata. So in our env, if we go back to that, we split those for the collection metadata and the NFT metadata. If you look at the URL that I posted, or that's like in that repo already, it's basically the same. I just didn't want to like split that up or like add another layer of confusion, but you can end up splitting that up if you wanted to. So let's go back here to our mint instruction. And then yet again, like here, I created a basic, for loop where you're just running through transaction, and it's basically just attempting a transaction, for each specific mint, and it's going through the number of transactions, which I'd set to 15,000, which is like the collection that we have. There is a better way of submitting match transactions here, and I'll be updating this week with a batch transaction type. So basically, you're just able to submit, these ahead of time, and it's not like, okay, is this going to go through? It's probably going to go through just because you're not hitting any of the rate limits here. But the way that I have it set, it ends up minting a good amount in a fair amount of time here, which is awesome. So that's basically the mint portion of this. You're basically just creating, who the owner is going to be. You're passing in all the program IDs and stuff. That's like usually what you have to do to interact with like any program or create any program instruction. Like if you were to mess with the SPL token program, you would have to pass in those program IDs to, create some sort of instructions. Here it's the same thing. You're just passing in the compression program, the bubblegum program ID. The bubblegum signer ends up being created through this like little function here. This is something that I ended up grabbing from, the Helios examples page. So like we actually have like a compression repo, and they have like a bunch of different, modification helpers here. And the bubblegum signer is one that you do need whenever you're like interacting with any assets here. And then yet again, like we're setting the metadata args and we're submitting the transactions. So like now if we were to go through and run npm run mint, we could go do that. It's gonna go through like a bunch of addresses. It's in a pretty inefficient way right now. So like you can see like a lot of these signatures end up like repeating. It's not submitting them again, or it's not messing up that signature, or it's not posting again. I think it's just like how the script ends up being, where it's just grabbing that signature that was produced and it's not grabbing another one for a bit of time. So like we left this open for about 135 transactions. And if we were to go through to our compressed test here, we can go over to the compressed assets, and we could see that like the collection mint was actually minted here, and that's like a little bit separate from it. And then we actually have the compressed asset itself. I ended up making this one like an HTML game, so feel free to switch this out with any JSON URI that you guys want to mint with. But you guys can pretty much go through and play this on like any iframe, anything that accepts like an iframe, and go through and play this. But basically, it's just going through and minting the assets here. And if you check our wallet value here, we're still at 0.75398. If I wanted to leave this mint open for a bit of time, which I'll actually do while we, clone X-ray, so we could just like, work with those assets a little bit. let's just leave it open for a bit of time and we'll see how much Sol is spent here. And if we're going to the wallet itself, I actually want to show you guys like what these transactions look like a bit here. So let's go to HTIM. This is the wallet that we're using. And we're going through and basically, going through all these transactions here. So if we were to look at one transaction signature of one that's minting here, you could see that, first of all, it's going to give you this instruction, mint to collection V1. If this was like a transfer or something, it'll, dictate that like really at like the top here. So if you're doing like a redeem or a decompress or a burn, it's really going to show that at this portion. And then it's like showing you like your metadata args. So basically you're able to see like all of that information that you're storing to these cNFTs. And you can verify it in this portion here if you wanted to, or you could just like quickly import it into like a wallet and check it out here. And as you can see, like we're not really even like dropping in Sol. We have 175 of these guys already, and we're still at 0.75321, and it's only dropping like 0.005 every few seconds here when it's minting and updating. So it's a really awesome feature here. But yet again, like here, if you want to like verify like how that's actually being minted, that's a really good idea. But from here, like you're not really spending anything. Like if you're looking at the fee of this, you're really just paying the fee here. So it's really awesome. Now I do want to go through something that like helps you like understand interacting with it or interacting with compressed assets, and that would be X-ray. X-ray will just quickly go through and actually clone. So let's get out of here. So let's do cd documents /encode. Let's do git clone X-ray. And this is very quick. Like we can get like a version up here in, I would say, less than 5 minutes actually. So if we grab the API key that we used, I won't go back to helios.dev to do that, but let's just grab this API key here. And let's go to our X-ray setup. So X-ray ends up having, and let me just minimize this a little bit. So X-ray ends up having a env template here that's set up where you can just paste in the API key. And this is all you need to run like a local instance of it. And we can just change this to .env. Ooh, let's not delete that. Let's just rename it. So we'll just rename this to this. CD into X-ray. Now X-ray ends up having, very quickly, it ends up having a, essentially like a lib folder here that has trpc. It's basically just calling like each action that you're using here. But essentially like right here, it's using DAS. So it's using the get asset, which is used to just like verify what an asset is, whether it's compressed or a regular asset. But it's using like all of these attributes that are returned here, and it's allowing you to interact with it. So like if I was to search this asset or search a compressed asset that I have through like drip or something, I'm able to do that a little bit easier. So just run npm run or npm install first. And then we will run npm run dev when this is done, just to get this back up here. npm run dev, perfect. And we'll get all the errors just because we didn't install a node ahead of time. But essentially we could go to our localhost 5173. And if we take a look at that, it might take a bit to initialize here. You could even like locally, host your own version of X-ray if you wanted to put it on like a Versal or some sorts, just fork it over. But in this aspect, it's just going to take a bit to load here. And essentially we're just going to have what we pretty much would have with like a regular X-ray here. And we're just getting our local instance set up here. I see that TPS is undefined here, so it must not be catching the key. But let's go through and make sure that this is saved here. Let's go npm run dev again. Just make sure that our key is actually being accepted. I'm just cleaning that up just because I'm a little bit picky with that. But But essentially, like if you wanted to take a look at like how like that's interacting with compressed assets on like any further basis, you could always do that. Regular X-ray, it goes to showing like the TPS up there. If I wanted to go through and go to like a regular compressed asset that I might have on mainnet here, let's get out of testnet. So let's go on to mainnet here. Let's go to drip season 2. Let's go to this guy, delicious promise 2. So you see like how the asset ID or the ID for the compressed asset returns like an empty account on something like Solscan. It's because it's not a token account, as we mentioned before. It's basically just something that's being verified on the Merkle tree itself. And you need indexers such as Helios to grab that information, but there's Helios, Triton1, there's Simple Hash, there's a variety of indexers that you can use. We're just probably the most reliable with using DAS at this moment. But essentially, like when you even search that ID itself, via being on like Solscan, it doesn't return anything. I'm pretty sure that even on mainnet Solana here, it doesn't return anything. So if like we were to search that, it's saying account does not exist. That's because this is using DAS to retrieve that information. So it's grabbing all the properties. It's even grabbing like who the current owner is, which is like my wallet, who the creators are, and then the compression aspect of it. So like what that tree ID is and what belongs to that. And you're able to get all that information. So I'd say that this is like a really good like step forward into one, being able to mint your own compressed assets. So by all means, use like shadow storage or Arweave to create your own JSON files and update these values yourself if you wanted to. But from there, use it to like interact in whatever sense you guys are building a project in. So if you're building like an NFT related project or an asset related project and you just need to retrieve that information to, for the user to interact with, do it this way. You would even use DAS to create transaction instructions with compressed assets. So the Soul Incinerator, they just ended up, where you're able to like burn NFTs. They were only allowing burn NFTs for regular token accounts, and now you can do it for compressed assets. Not that you would get a ton of Soul back anyway, but if you wanted to get those assets out of your wallet, because some of them in the future can be spammy, you could use that. But there's a variety of different ways that you could use a collection of DAS, which I don't know if I sent over that documentation to you guys, but let me do that. But you could use a combination of DAS and or whatever endpoints you guys are using to accomplish that to create your applications. And it's really cool what you can end up doing with it. I think I did send the Helios.dev one, but here is the documentation to the DAS API. And this ends up being a very good tool here for, looking over like any copy paste examples that you could have or that you could use to set up these like endpoints. So like we have like very standard like, examples here where like you could essentially just copy and paste this over and you can retrieve an asset ID, or you could retrieve all the assets that belong to an owner, whether it's compressed or regular, or you could even go through and grab all of the collection NFTs. And we even have one that has pagination available. And from there, you could even store that, into being like a collection mint list tool, or, being some sort of, I would say, grabbing any type of like portfolio data for like a user. You can end up doing, a variety of things. But essentially, like however you're building your application, if they involve any sort of asset, whether you're building a game on chain or whether you're building, some user profile centered app, I mean, this ends up being pretty beneficial. So I would look through this documentation if you have any questions. It's something that even like X-Ray uses. And then like we even have the newest endpoint that we released, which is get signatures for an asset, because you're not able to, grab like a token account and say, hey, or grab all of the signatures for this. You now have like this endpoint where you're able to just put in the asset ID for the compressed asset and return the load of signatures. So it'll say like, okay, this was a mint to collection V1 and here was its signature, and this was a transfer and here is its signature, and you're able to look through that. So you can end up doing and using compression in a lot of the ways that you would use like a regular, NFT token that's stored into a token account. But this way you're still getting something that's stored on chain. It's just coming at 1% of the cost. And if we were to look at this here, we have about 3,000 transaction instructions. I'm pretty sure we won't have 3,000 NFTs that were set here, but if we go to our compressed test here and we go back to our developer settings, put this back on test mode, and I'm using Phantom. You could use any wallet that you prefer here. And we were to look at the amount of NFTs that were minted here. It's not going to be 175, and Phantom may have reached its limit here with showing us how much has been minted. Okay, so now we're at 1426. So that's a lot of NFTs, and it's more than most people ever have. And if we were to look at how much Solana we have 0.747. So I don't think we even spent 0.02 Sol on minting 1500, which is pretty wild. So it's something to like look at. Like obviously I left this open for like a bit of time. I'm going to be setting up the mint instruction to be a little bit better here, but I also want to leave some time open for any questions that you guys might have. And if you guys don't have any questions, I guess like during, this session, you guys could always like reach me on Twitter. My name is Solhosty, so SOLHOSTY. And that is the same as my Telegram user. So if you guys have anything or any specific question to like how your project is being built, just message me there. That's my handle on Telegram and Twitter. But I do want to leave the floor open for like any questions that you guys might have now.
Cool. Yeah, thank you very much. And yeah, guys, you can pop any questions in the chat if you had them. We actually don't have that much time. We've got like 3-4 minutes left. So if you have any questions, now is the time. And in the meanwhile, I'd like to ask, so what kind of use cases would you like to see built for this hackathon specifically? Like, okay, your bounty is very open, like build any kind of compression project on Helios, but what do you think is very much useful, and what do you think would improve the, would be cool to be built from the hack?
More game assets, I would say. Like I think Solana in general has like a lack there of like Solana, gaming programs or Solana gaming dApps. That would be really cool to see. We wanted to mostly leave it open just so people ended up, just being able to go off of like their own, I guess, like creativity or like maybe their own like mindset of like what they're building. And a lot has been not done yet in compression, where like when you do it, you'll probably be the first person to do it. So that's a very exciting aspect of it.
Yeah.
After the NFTs are minted compressed, they could be traded regularly. Yes, they could be traded regularly on something like Tensor. Tensor supports compressed assets. If you're, and Magic Eden is actually working towards something like that as well. So it's going to be a very regular thing when you're working with compressed assets. But to get back to the original point, I would like to leave it open. But to see more game, use cases for it, that would be awesome to see. We just see very little of those, but game receipt aspects of it, like very in real life aspects that I guess haven't been used. A lot of it has just been comparing to like generative collections, but that's not where it's going to be stopping, I don't think. So I would say gaming first of all, but secondly, if anybody has any custom idea, I mean, you'll probably be the first to do it, and that'll be amazing. So
yeah, of course. Yeah, I think that about brings us to the end. We don't have any more time left. But yeah, thank you very much, Hunt, for coming and holding a wonderful workshop. And thank you to everybody else for listening in on the workshop. And I hope you enjoyed it as much as I did. I will see you tomorrow at the same time for the Phantom workshop. And until then, have a nice day. See you guys.
all right,
Bye.
guys, have a good day. Thank you, guys. Bye.